Homework 24 is the start of Chapter 6. However, some of these problems are still in that same section as our trigonometric functions. In fact, all of Homework 24 is going to be in the same slice of the pie, even though we've moved to a new chapter. These ones are going to look very familiar to you. We've done some that were problem type 1 already. Now we're going to do problem type 2, which we're basically going to do the same way. And so I'm going to say theta is an angle in quadrant 3. So my reference angle is over here in quadrant 3. I know that my sine is equal to negative 3/5. Sine is the opposite over the hypotenuse. So the opposite side is negative 3. You can see it's going down. My hypotenuse is 5. I want to find the missing side using my Pythagorean theorem. So negative 3 squared plus x squared is going to equal 5 squared. Negative 3 squared is 9, so 9 plus x squared equals 5 squared, which is 25. If I subtract 9, x squared equals 16, so x is equal to 4. Now, we can see that this is going in the negative direction, so even though we got x equals 4, we know it's plus or minus 4, and that we actually have to use the negative 4, since we're over there in quadrant 3. Then we can answer the questions, because now we have our reference triangle drawn. So secant. The secant is the inverse of the cosine. It's going to be the hypotenuse over the adjacent. And we're also going to do cotangent. Cotangent is the inverse of the tangent, so we have adjacent over opposite. So secant, hypotenuse over adjacent, 5 over negative 4. So we're going to say negative 5/4 because we like the negative in front instead of on the bottom. Cotangent, adjacent over opposite, negative 4 over negative 3 is going to give me a positive 4/3. So just like we did before, if we can draw a reference triangle in there, find our missing side, we can then go ahead and answer. Keep in mind, if you've forgotten, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. The cosecant is the inverse of the sine, so hypotenuse over opposite. The secant is the opposite of the cosine, or the inverse of the cosine, so hypotenuse over adjacent. Cotangent is the inverse of the tangent, so adjacent over opposite. So if you've forgotten those or don't have those memorized, we can go from there. If you don't have those memorized, you might want to memorize them because we're going to do a lot of that during trig class, as if we haven't already. So let theta be an angle in quadrant 2. Quadrant 2 over here, my cosine is negative 12/13. The cosine is the adjacent over the hypotenuse, so negative 12 and 13. So using my Pythagorean theorem, negative 12 squared plus x squared equals 13 squared. Negative 12 would be 144. 13 squared is 169. If I subtract my 144, x squared is going to be 25, so x equals 5. It is going in the positive direction, so it is a positive 5. And now I have my reference triangle all labeled. I can go ahead and answer my question. Cosecant. Cosecant is the inverse of the sine, so we have hypotenuse over opposite. Cotangent, inverse of the tangent, so adjacent over opposite. So my hypotenuse is 13, my opposite is 5. I'm going to have 13 over 5 then. My adjacent over my opposite, negative 12 over 5, so negative 12/5. Number Number 3, let theta be an angle in quadrant 4. So quadrant 4, my reference angle's over here. My cosine is 5/8. My cosine is the adjacent over the hypotenuse, so 5 and 8. Using my Pythagorean theorem, 5 squared plus x squared equals 8 squared. 25 plus x squared equals 64. If I subtract my 25, that's not going to go in there as nice as we had before. 39. X squared is going to equal 39. So I'm just going to have to do the square root of 39. It is going in the negative direction, so I'm actually going to have negative square root of 39. Got my reference triangle drawn. I'm going to do cosecant. The cosecant is the inverse of the sine, so hypotenuse over opposite, and tangent. Tangent is opposite over adjacent. So hypotenuse is 8 over the opposite, negative square root of 39. So if I have 8 over negative square root of 39, we have to rationalize the denominator. Take it times the square root of 39 and times the square root of 39. They're going to put the negative in front, so I get negative 8 square root of 39 over just the 39 when I simplify that. Tangent, opposite over adjacent. The opposite is negative square root of 39. The adjacent is 5. So I'm going to have negative square root of 39 over 5. Again, I'll put the negative in front when you get it typed in, but it's going to look something sort of like that. The next ones, we are doing the same as the previous ones. We're just on problem type 3 instead of problem type 2. So now they're going to give us not the common ones to start with, but doing the same thing. Let theta be an angle in quadrant 2. So we're over here in quadrant 2. We're going to start with the cosecant of theta is equal to 5. That means we have 5 over 1. Cosecant is the hypotenuse over the opposite. So the hypotenuse is 5, the opposite side is 1. I need to find my missing side. So 1 squared plus x squared equals 5 squared. 1 plus x squared equals 25. If I subtract 1, x squared equals 24. I'm going to do the square root of 24, and I can simplify the square root of 24 because it is 4 times 6, so 2 square root of 6. Now this is going in the negative direction, so I'm actually going to use negative 2 square root of 6 in my reference triangle. I am going to find the tangent. Tangent is opposite over adjacent. I'm also going to do the cosine, which is the adjacent over the hypotenuse. So, the opposite over the adjacent, I'm going to have 1 over negative 2 square root of 6. I have to rationalize the denominator. Don't have to worry about the 2. I'm just going to multiply by the square root of 6. So negative is going to be in front. I'm going to have square root of 6. 6 is going to be the value there when I take the square root of 6 times the square root of 6. So negative, or 2 times 6 is going to give me 12. I move the negative out in front. So I end up having negative square root of 6 over 12 for my answer. I should have put my cosine down a little bit, but that's okay. My cosine is my adjacent over my hypotenuse, so all I'm just going to do is put negative 2 square root of 6 over my hypotenuse of 5. Again, they'll put the negative out in front, so negative 2 square root of 6 over 5 would be my cosine. Number 5, theta is going to be an angle in quadrant 3. So I'm going to draw my reference triangle here in quadrant 3. I know the secant is negative 5/2. Secant is hypotenuse over adjacent. And so my hypotenuse is always a positive number. So my hypotenuse is 5. the adjacent side is going to be negative 2, and you can see that the adjacent side is going in the negative direction, so that would make sense. 5 over negative 2. I want to find my missing side. So negative 2 squared plus x squared equals 5 squared. 4 plus x squared equals 25. If I subtract 4, x squared equals 21. So x is going to equal the square root of 21. 21 I can't simplify. It is going in the negative direction. So negative square root of 21 is going to be my missing side. Going to find my cotangent and my sine. So my cotangent is my adjacent over my opposite. My adjacent is negative 2. My opposite is negative square root of 21. I have to rationalize my denominator. I got a negative over a negative, so it's going to be positive 2 squared root of 21 over 21. Can't simplify that any farther than that. So that's going to be my answer for cotangent. My sine. Sine is opposite over hypotenuse. The opposite is negative square root of 21 over 5 then. Of course, they'll put the negative in front. And so negative square root of 21 over 5 would be the sine of my angle. Number 6, same kind of thing. Theta is going to be an angle in quadrant 2. I know that my cotangent is negative 2 square root of 6, which I'm going to write as over 1. And so cotangent is the adjacent over the opposite. So my adjacent is negative 2 square root of 6. It is going in the negative direction. My opposite is 1. It is going in the positive direction. If my lines were going the other way, I'd switch my sign so that the top was positive and the bottom was negative. But it worked out. The top is negative, the bottom is positive. I got to use my Pythagorean theorem. So 1 squared plus negative 2 squared is 6 squared equals x squared. Well, 1 squared is 1. Here I have to multiply. Negative 2 squared is 6 times negative 2 square root of 6, which is positive 4 square root of 36, or 4 times 6, 24. One plus 24 is 25, and so x is going to equal 5. It is my hypotenuse, so it will be positive because my hypotenuse is always positive. I am going to do the sine. The sine is the opposite over the hypotenuse. So opposite over hypotenuse is 1 over 5. And I am going to do the secant. The secant is the hypotenuse over the adjacent. The hypotenuse over the adjacent would be 5 over negative 2 square root of 6. And there's one again I have to rationalize. So I'm just going to multiply by the square root of 6. I have a positive over a negative, so it's going to be negative 5 square root of 6 over the square root of 6 times the square root of 6 is 6. 6 times the 2 is 12. So I get negative 5 square root of 6 over 12. The next ones we are going to find the exact values of some common angles, our reference angles, the 0, 45, and 30, 60, 90 triangles. And so 2 ways we can do this. We can either use our calculator, since we're doing the inverse sine, cosine, and tangent. Remember that if it's cosine to the negative 1, that means inverse cosine. Arc tangent is the same thing as inverse tangent. On your calculator, you're going to see it like this. Books sometimes use arctangent instead of the negative 1 exponent. So those things mean the inverse of whatever your angle is. 2 ways we can do this problem. One is by using our calculator. One is by using our handy-dandy table. We had this table way back at the beginning of the trig section with our common angles and what the sine, the cosine, and the tangent. Remember, we drew the reference triangles and we figured all that stuff out. If you go to Linda's note sheets under your resources, the table's going to be there for you to print out. Sometimes you have to use the table. Your calculator doesn't work very well if you're doing the next ones where we have to do the tangent of something or other. So, tables here, calculator, that will work on these ones here either way. Now what you have to be careful of is when you're doing the inverse of sine, cosine, and tangent, is that for sine and for tangent, you want your answers to be between negative pi over 2 and positive pi over 2, which means you're looking for quadrant 4 or quadrant 1. If it's positive, you're going to be quadrant 1. Negative, you're going to be in quadrant 4, but you're going to do the negative angle instead of the positive angle. So instead of 330 degrees, you do negative 30 degrees. For cosine, you're going to stay between 0 and pi. So you're going to stay in quadrant 1 or quadrant 2. Now your calculator knows this, but if you're using the table, you got to make sure you're looking at the right spot. Because sine is positive in 2 different quadrants, we're going to use the one from quadrant 1. Tangent is negative in 2 different quadrants. We're going to use the answer from quadrant 4 and then make sure we use the negative reference angle. So, if I'm going to use my calculator, again, I have to be careful on how I punch this in so the calculator interprets the right way. To do the inverse sine, we're going to do shift and the sine button. So I'm using the Casio one. If I do shift in the sine button, it gives me the inverse sine, sine to the negative 1. In parentheses, we're going to do the square root of 2 divided by 2. You can't use the fraction button or the calculator reads it to be square root of 2 over 2 all under the square root. You want it to be separate, the square root of 2 divided by a plain 2. So you have to do it this way. If we do that, parentheses, square root of 2 divided by 2, it's going to give you your answer in degrees because your calculator is in degree mode, 45 degrees. I want my answer in terms of pi, so I have to convert it into radians. Pi over 180, and if I reduce, this goes into here 4 times, so I'm going to get pi over 4 for my answer. So if I'm using my calculator, that's what I would do. If I was using the table, let me bring up a table here for you. I'm going to go into my notes. This one was... There it is. Values of inverse trigonometric functions. And at the end, I'm going to have this great big table here that you may or may not be able to read on the screen, but I'm going to bring it up. But again, you might want to have that. Now, we were doing over here, that moved, the inverse sine of square root of 2 over 2. Since this is positive, we're going to be in quadrant 1. So we're going to go over here to our table. These are our angles in quadrant 1. Since I'm doing the sine, I'm going to look for square root of 2 over 2. Square root of 2 over 2 is right here, which corresponds to radian measures of pi over 4. So remember with sine, you're going to either use quadrant 1 or quadrant 4, but if it's in quadrant 4, you're going to use the negative measure instead of the positive measure, and so I would have to subtract from 2 pi and use the negative angle measure. if I go back to the next one here, the next one says we are going to do the inverse cosine of negative square root of 3 over 2. So we would do shift and the cosine of negative square root of 3 divided by 2. So your calculator interprets that the right way. So shift and the cosine, parentheses, negative square root of 3 divided by 2, close my parentheses, gives me 150 degrees. Cosine needs to be in quadrant 1 or quadrant 2. We are in quadrant 2, 150 degrees, but we need it in radian measures. So pi over 180, reducing that down, 15/18 I can divide by 3, so 5 over 6. So 5 pi over 6 is going to be my answer. If I'm using the paper, if I'm doing the paper, I have to be in quadrant 1 or quadrant 2. I'm doing the cosine. The cosine is negative in quadrant 2. It's positive in quadrant 1. So I'm looking for where do they have negative square root of 3 over 2. You can see right here is negative square root of 3 over 2 corresponds to 5 pi over 6 on my table. So cosine 5 pi over 6. So I would practice it both ways because, like I said, some you have to use the table on. You can't do it on your calculator. And so you want to get used to doing it either way. So here, number 9, we want to find the inverse tangent or arctangent of 0. So I'm going to do shift tangent of 0. Don't really need the parentheses. It wouldn't hurt to put the parentheses there, but I don't think you really need it. Shift. So shift tangent gives you the inverse tangent of 0, and I get an answer of 0. Inverse tangent of 0 is 0. If I'm using my paper, going over to my paper, if I look right here, here's my tangent. Tangent value is 0. You can see I have an answer of 0, and 0 is between positive 90 and negative 90. And so I have the correct one. I wouldn't want to use the one that has 180 because 180 isn't between our negative pi and our positive pi. So 0 is going to be my answer. On the next ones, we're doing the composition of a trigonometric function and an inverse trigonometric function. And you would think that when I do one and I undo the other one that I always get the same answer. Sometimes I do, but sometimes I don't because of the discrepancy of which quadrants I have to stay in for my answers. So keeping in mind again that sine you have to be in quadrant 1 or quadrant 4, sine and tangent. Cosine you're in quadrant 1 or quadrant 2. And so, I am going to first of all figure out what the sine of 3 pi over 4 is. So, again, I'm going to use my table. Hopping over here, the sine of 3 pi over 4. So here's 3 pi over 4. It's 135 degrees. You could do 135 degrees on your calculator, but you need to change it from radians into degrees because our calculator's in degree modes. So cosine of 3 pi over 4 is going to be negative square root of 2 over 2. Oh, I'm doing sine. So you got to remember which one you're doing. And my board wanted to move. So sine of 3 pi over 4, going back over here. 3 pi over 4 of sine is square root of 2 over 2. So this answer here is square root of 2 over 2. I now want to do the inverse sine of square root of 2 over 2. So I want to keep in mind that when I do the inverse sine, since this is positive, I'm going to be in quadrant 1. And so I go over here and I'm looking for square root of 2 over 2. The inverse sign then is going to be pi over 4. So my answer here going to end up just being pi over 4. So the sine of 3 pi over 4 was square root of 2 over 2. But then when I did the inverse sign, I had to go back up to quadrant 1 since my sign was positive. And so the inverse sign of square root of 2 over 2 would give me pi over 4. 11, we're going to do cosine. First of all, we're going to find the cosine of 7 pi over 6. So 7 pi over 6, my cosine is going to be negative square root of 3 over 2. So I'm going to do the inverse or arc cosine of negative square root of 3 over 2. So again, I got to think about cosine. Cosine is going to be negative in quadrant 2. And so I'm going to look at my paper for quadrant 2 for negative square root of 3 over 2. So quadrant 2 would be right here between 120 and 180. I'm doing the inverse cosine. Negative square root of 3 over 2 is going to be 5 pi over 6. So 5 pi over 6 should be my answer there. The third one. On the third one, we're doing the inverse cosine of negative square root of 2 over 2. My cosine is negative in quadrant 2. Quadrant 2. And so on my paper, I'm looking for negative square root of 2 over 2 in quadrant 2. Quadrant 2, cosine negative square root of 2 over 2 would be at 3 pi over 4. So now I'm going to do, my board moved again, the cosine, cosine of 3 pi over 4. So now I'm going to go back to my paper. I'm going to look at 3 pi over 4. 3 pi over 4, I'm going to do the cosine. My cosine happens to still be negative square root of 2 over 2. So my answer here is negative square root of 2 over 2. That one's one where you happen to get the same number. Doesn't always happen that way. So that's if I have to use my table. The next ones we are going to use ones that we have to use our reference triangles to draw. So 13, 14, and 15, we're doing the composition of trigonometric functions, problem type 2. Problem type 2, instead of using the table, since we're doing all the inverse functions first, we're going to draw our reference triangles. Notice none of these have pi in them, like on the previous ones where you had radian measures. So that's my hint or my sign to know which one I'm doing. Do I have pi in the problem, or do I have problems without pi in there that I can draw my reference triangle? So I'm going to do the inverse cosine. So if I'm doing the inverse cosine, I know I have negative 1 over the square root of 5. Cosine is going to be negative in quadrant 2. Cosine is the adjacent over the hypotenuse. So the adjacent is negative 1. The hypotenuse is a positive. It's always a positive, square root of 5. I can find my missing side by using my Pythagorean Theorem. So negative 1 squared plus x squared equals the square root of 5 squared. So this would be 1 plus x squared equals 5. If I subtract 1, I'm going to get 4. So x is going to equal 2. My x is going up, so I'm going to get a positive 2 for my missing side over there. Now I'm going to do the sine of my triangle that I have drawn over there. So my sine is my opposite over my hypotenuse, so I'm going to have 2 over the square root of 5. Of course, I have to rationalize that denominator, and so I get 2 square root of 5 over 5 for my answer. The next one, we are finding the tangent of the inverse sine of negative 15/17. For my sine to be negative, I want to be in quadrant 4. So I'm going to draw my reference triangle over here in quadrant 4. My sine is the opposite over the hypotenuse. So negative 15/17. I have to do my Pythagorean Theorem. So negative 15 squared plus x squared equals 17 squared. I don't know those ones in my head. Well, 15 is 225, but... So 15 squared is 225 plus x squared equals 17 squared, 289. So if I subtract my 225, I get 64, and the square root of 64 means I'm going to have 8. 8 is going to be in the positive direction, so I have a positive 8 there. I'm now going to do the tangent of my reference triangle. My tangent is my opposite over my hypotenuse. Oh, my tangent is not my opposite over my hypotenuse. My tangent is my opposite over my adjacent. Looked over here and saw that. So tangent is opposite over adjacent. The opposite over the adjacent means I'm going to have negative 15/8. Number 15. I am going to do the inverse cosine. My cosine is positive, so since I'm positive, I'm in quadrant 1. For all of them, sine, cosine, and tangent, if it's positive, you're in quadrant 1. My cosine is the adjacent over the hypotenuse, so 7 over 8. So, doing my Pythagorean Theorem, 7 squared plus x squared equals 8 squared. 49 plus x squared equals 64. I'm going to subtract my 49. I get 15. Can't simplify the square root of 15. It is in the positive direction because it's going up. And so now I'm going to do the cosecant. Cosecant is the hypotenuse over the opposite. So 8 over the square root of 15. I have to rationalize my denominator, so I get 8 square root of 15 over 15 for my answer. And again, on the next one, we're doing the composition of trigonometric functions type 3. Notice again, we're in radian measures, and so I've got to use my chart, my table here, in order to look up my values on here. This one you could probably do by drawing the reference triangle, but that one's, again, one of your common ones. And when you do those, you're either going to have your 30, 60, 90 triangle or your 45, 45, 90 triangle, or be right on the axis at 0, 90, 180, or 360. So we're going to just go ahead and use our tables when we figure this one out. So we're going to start off by looking up what the sine of 2 pi is. So I can get my board to stay where I want it to be. When we flip back and forth, we might find what we want. Sine of 2 pi. 2 pi is going to be way on the bottom. 2 pi. My sine is 0. So Going back over here, I want to find the inverse tangent of 0 then. So inverse tangent of 0, keeping in mind that I want my answer to be between negative pi over 2 and positive pi over 2. 2 pi is not between there, so I can't have that same thing. Plus, I'm doing tangent. So I'm doing the tangent of 0. I want it to be in quadrant 1 or quadrant 4 if I do the negative. So I'm going to go back over here, up here in quadrant 1, if I check my tangent being 0 is 0, so my answer is going to be 0. So in this case, I just get 0. Number 17, we are doing the cosine of pi over 4. So looking over here, cosine of pi over 4, I've got to move my table. Pi over 4, my cosine is square root of 2 over 2. So I am then going to do the inverse sine of square root of 2 over 2. That's a positive value. Since it's positive, we're going to be looking in quadrant 1. So looking in quadrant 1 for the sine being square root of 2 over 2, we get pi over 4. So pi over 4 happens to be my answer. And one last one there, number 18. If I move the board up to number 18, we are doing the inverse cosine of square root of 2 over 2. Again, this is positive, so we're looking in quadrant 1. So, square root of 2 over 2, it was positive. Let me look for sure. Yes, it was positive. Square root of 2 over 2 in quadrant 1 would be pi over 4. So now we are going to do the tangent of pi over 4. So going back to our table, pi over 4, if I look to see what the tangent is equal to 1. 1 is going to be my answer then. So, print this out, keep it handy. You're going to use it for a lot of problems. Sometimes you can draw the reference triangles, but if it's the common ones, and especially if you notice they're using radian measure in there, then you want to use this table here. Do again, be careful if you get an answer like 300 degrees that you make it the negative. So 5 pi over 3 would be negative pi over 3 instead.